So as you know that 8 p.m. is the timing for mechanical engineering practice session, and I'm back again with some more important questions for RRB JE 2024 with my game changer series. So very good evening to everyone and welcome to this session. Good evening all of you. Welcome back to another set of practice, another set of session where we are I'm back again with some exam focused question or practice question series for RRB JE 2024 exam. So good evening everyone and welcome to this session. Please reply me in the comment box if my audio and video is fine and you're getting the clear video and audio for this session. Good evening guys, good evening, welcome to the session. Good evening my friends, very good evening. How are you guys? Just let me know if my audio and video is clear to you. Yes everyone, is my audio video fine? Okay, Neeraj, good evening, welcome to the session. You are the first student to join the session. I think yesterday also you were there. So I like the students who are consistent and on time. So let's start the session. So dear students, if you have not subscribed to our YouTube channel yet, then please do it. And also you can just press the bell icon just next to the subscribe button so that you never miss any videos from our YouTube channel. Also take out few seconds to like and share the session also. This is my small introduction for those students who are watching this session for the first time. I'm Vikas Sir, Faculty of Mechanical Engineering, and this is my mail ID. You can just mail me here if you are having any query. Okay. Hello Renault, good evening. कैसे हैं आप? This is my Telegram, Mechanical by Vikas Bhadoria. You can just join me over here. Okay. Teaching experience 7+ years, subjects taught, qualification, achievements. Coming to the first question, I'm not going to waste your time. I know that you guys come to the session for practice of the question. So let's quickly jump to that. A researcher claims that he has built a heat engine that operates between 27 and 10 degrees Celsius. This engine produces 10 kilowatt of work and rejects 165 kilowatt of heat. This engine is, yes. What can we say about this engine? So first of all, for this particular engine, the efficiency of the engine can be written in terms of temperature as 1 minus lower temperature by higher temperature. It is 1 minus, what is lower temperature here? 10 degrees Celsius, which is 283 Kelvin, divided by higher temperature is 227. So you can get the value of efficiency from here. Hello Harsh Rajbar, good evening. Just give me 1 second, okay? Just give me 1 second. Yeah, just solve this question, I'm just coming. Yes, everyone. Actually, there was some problem with the weather in my area, and so I have to just get my clothes from outside. It started to rain. So let's start. So this was the first question of today's session. Yeah, just give me 1 second. Yeah. So I was just telling you, firstly, you need to find the value of, hello धर्मेंद्र कुमार सरोज, ये क्लासेस डेली होती हैं? यस, बिल्कुल डेली होती हैं. तो यहाँ से आपकी एफिशिएंसी आ जाएगी. यू विल गेट द वैल्यू ऑफ एफिशिएंसी फ्रॉम हियर, एंड एक्चुअल एफिशिएंसी ऑफ द इंजन विल come from here. This is Carnot. Okay, you will get actual efficiency as work output by heat supplied. Work output is 10 kilowatt, heat supplied will be heat rejected plus work, which is 10 by 175. So you will get one efficiency from here and one efficiency from here. Now you just need to compare it. आप इनको compare करिए. क्या आएगा compare करके? 283 divided by 300. So you will get 5.67% this efficiency, and this you will get as 10 divided by 175. You will get 5.714. 0.714. It's difficult to say, it's difficult to comment on the efficiency because they are very close. Okay, this is 5.67%, this is 5.714. Ideally what you can say, there are two things. Either you can say actual efficiency is almost equal to Carnot. If this is the case, or it can be less than the Carnot, Carnot efficiency is less than, almost they are same. So we can say this is possible. Okay, you can say this is the case of possible. Okay, actual efficiency is 5.67 and 5.71. But yeah, if you don't take approximate value, if you don't take approximate value, then in that case you can say that this is 5.71, this is 5.67. So in that case you can say actual efficiency is more than Carnot. So if I don't take approximate value, तो आप इसका आंसर ऑप्शन ए इम्पॉसिबल ही मार्क करेंगे. If you don't take approximate value, okay? If you say that, yeah, this is 5.714, this is 5.67%, and if you don't approximately take it as 5.7, then in that condition, this will be the case of impossible. Although this can be possible and reversal also if you take this approximately as 5.7. Okay. What will be the volume of 1 kg of the steam at 80 degrees Celsius having dryness fraction of 0.9? At 80 degrees Celsius, specific volume of saturated liquid is this, and vapor is also given. So how to find the total volume? The total specific volume is equal to volume of the liquid plus dryness fraction into volume of the vapor minus volume of the liquid. So from here you will get the total specific volume, which is Vf 0.001 plus dryness fraction 0.9. रिवर्सिबल होगा. वही मैंने कहा इसमें, इस कंडीशन में, कि इफ यू अप्रोक्सीमेटली इफ यू टेक 5.7 and this is already 5.714, if approximately you take it as 5.7, then this can be so I cannot 100% say, I have to just check it. Okay, if this is a previous year question, I have to check it once and what they have taken as the answer, because if they are taking the approximate value, then this will be a reversible one and possible. So I have to just check it. Yeah, it's not given anywhere. The answer is not given anywhere. So it's totally your wish. If you take it as, see, if you take this value as, if you take actual efficiency as 5.714 or 5.71 and Carnot as approximately 5.7, approximately, then this can be reversible also. Okay, it's totally your wish what you want to take. because the option is not given for this question. If you take approximate value, the answer can be option D also. If you don't take approximate, it can be option A also. Okay. But you need to remember this fact that if actual efficiency is greater than Carnot, it will be impossible. Okay. If actual efficiency is equal to Carnot, it will be reversible and possible. Okay. So both the cases can be there depending on if you take approximate value, this will be reversible. If you don't take approximate, it will be impossible. For this question, what will be the answer? This will be 3.4 minus 0.001. From here, you will get total specific volume. So total volume will be equal to mass into total specific volume. The mass is already 1 kg. So 1 kg into this you will get total volume. So from here, you can get the answer. If you solve it, you will get this value as 3.0601. Okay. I don't know what the reason they have given the answer in meter. This should be meter cube, not kg. तो ये मीटर क्यूब में होना चाहिए, kg में नहीं. Okay, ऑप्शन क्या होगा इसका राइट आंसर? Option D will be the right answer. Okay, so the answer should be meter cube. Next question. The operating temperature of a cold storage is -9 degrees Celsius and the load for the refrigeration plant is 20 kilowatt for ambient temperature of 24 degrees Celsius. Actual COP of the plant is 1/4 that of ideal plant working between same temperature. The power required to drive the plant is. देखिए इस क्वेश्चन में आपको लोअर टेम्परेचर दे रखा है. द लोअर टेम्परेचर इज -9 डिग्री सेल्सियस. You can convert that in Kelvin. The higher temperature is also given, which is 24 degrees Celsius. Convert that in Kelvin. And actual COP is equal to 1/4 of ideal COP. Ideal COP means the COP based on reverse Carnot cycle. So first of all, you need to find the ideal COP. Ideal COP will be lower temperature divided by higher minus lower temperature. From here, you just put the values in Kelvin and then solve the question. So this will be 264 divided by 33. From here, you will get the value of the ideal COP, and actual COP will be equal to 2. Now actual COP is equal to desired effect. What is the desired effect? This is the desired effect, 20 kilowatt divided by power input. So actual COP is 2. So this you will get answer option C. Okay. Are you all getting option C as the answer? Tell me. Simple. Next question. A heat reservoir at 800 Kelvin is brought into contact with ambient at 200 Kelvin for a short time. During this period, 1200 kilojoule, 12,000 kilojoule of heat is lost by the heat reservoir. The total loss in the availability due to this process is. इस क्वेश्चन के अंदर आपसे ये कहा जा रहा है that the heat reservoir, which heat reservoir is losing the heat? Which reservoir loses the heat? The reservoir at high temperature. High temperature reservoir always loses the heat, and that heat is 12,000 kilojoule. It is losing the heat, but actually that is heat supplied, right? And in this question, you have to find the total loss in availability. This is lower temperature is 200 Kelvin, or which is ambient temperature. Total loss in availability is nothing but it is called as irreversibility. It is called as irreversibility, right? How you will find the irreversibility? This is also known as total energy. Total energy. If this is the ambient temperature, this is the ambient temperature or surrounding temperature 200. So you can get the value of maximum work from here. Maximum work which is available energy will be Q 1 minus T naught by T. Q is 12,000. 1 minus T naught. T naught is how much? 200 divided by 800. So you will get the value of maximum work from here. Maximum work is nothing but available energy. Available energy you will get from here. What will be the available energy? Tell me. So you will get this value as 9,000 kilojoule. Maximum work or available energy will be 9,000 kilojoule. Now, if you remember the relation, total energy is sum of total energy is equal to available energy plus irreversibility or unavailable energy, you can say that. So, or it is loss of available energy. So if this is 12,000, if this is 9,000, what will be this? You can easily get the value 3,000. Clear? Is it clear to everyone? How you get this formula? You know that you must remember this relation, that work is equal to Q minus T naught into ds. This is available energy, this is total energy, and this is unavailable energy. From here you can get this relation. Identify whether the following statements are correct or incorrect. A reversible adiabatic process is necessarily isentropic. A process which is reversible and adiabatic will necessarily be isentropic. An isentropic process is not necessarily a reversible adiabatic. First of all, a process which is reversible adiabatic. Reversible, that means entropy generation will be 0. And adiabatic, that is heat transfer, will be 0. For that, entropy change will be 0 or entropy will be constant, and this will be isentropic for sure. So statement number A is 100% correct. But in this case, statement number B says an isentropic process not necessarily reversible adiabatic. Yes, that is correct, because in case of irreversible process, also, there is a case for which you know that entropy change is equal to Q by T plus entropy generation. There is a case where if heat is rejected, and this is negative, temperature is positive, and entropy generation is always positive, then there can be 3 cases for entropy change. This can be positive, this can be negative, this can be 0. That means in case of irreversible process also there can be a possibility that entropy change can be 0, or entropy can be constant, or it can be isentropic. That means isentropic process necessarily not be reversible adiabatic. So this is also correct and this is also correct. Both statement A and B are correct. Clear? Yeah. Very good. Those who have given option A as the answer. Next question. Superheated steam at 3 bar and 150 degrees Celsius expand isentropically to 1 bar. A specific entropy of the superheated steam is given, and at 1 bar pressure, the specific entropy for liquid and vapor is also given. You have to find the dryness fraction of steam at 1 bar. So superheated steam is undergoing expansion. If you have to represent this on temperature and entropy diagram, you can show it like this. Okay, superheated steam is undergoing expansion. Okay, like this, from 1 to state number 2. All right. Now, at point 1, the entropy is equal to 7.078. and this point 2 is in the wet region. You have to find the dryness fraction at this point. How you will find this? You know that this is isentropic expansion. For isentropic process, entropy at point 1 will be equal to entropy at point 2. Since point 1 is in the superheated region for which entropy is given 7.078, and point 2 is in the wet region for which entropy will be SF plus X times of Sg minus SF. Okay, put all the values, you will get 7.078 is equal to 1.303 plus X into 7.36 minus 1.303. From here you will get the value of X. Okay, what is the value of X? 0.953. Are you all getting the same value? Let me just check it. Yeah, 0.953. Okay, so this will be the answer for this question. Next question. Sorry. Next question, a turbine produces 6750 watt at 300 rpm under net head of 45 meter with overall efficiency of 25%. What would be the power in kilowatt for the same turbine under net head of 60 meter under homogeneous condition? What do you understand by homogeneous condition? Homogeneous condition, that means we are comparing both the turbines, okay, under same, basically the make is same, okay, that is the diameter is same, everything is same. Only thing is the operating head is changed to 60 meter now from 45 meter. Okay, so how you will solve this question? Because they have given a lot of data here, but what is being asked in the question? The power when the head is changed. Is there any relation between the power and head? The power and head, the unit power is equal to power by h power 3 by 2. There is one relation for this unit power where power and head are related like this. Okay, but there is one more relation of overall efficiency. Overall efficiency is equal to shaft power divided by rho g QH. Okay, okay, from this relation you can say the power is directly proportional to the head. Okay, so which relation should be used? This one or this one? Tell me, which relation should be used in this case? If you are comparing the same turbine under homogeneous condition, then you have to use this condition for unit power. Okay, so if you compare it, this will be P2 by P1 will be equal to H2 by H1 power 3 by 2. Okay, so P2 by P1, P1 is 6750 is equal to H2 is 60 and this is 45 power 3 by 2. Solve it, tell me the answer. 10.59. Okay, you are saying 10.59. Let's check it. Yeah, so you will get 10392 watt, or approximately you can say 10.39 kilowatt. 10.39 you are getting for this question. 10.39 is not there, exactly not getting 10.39, but it is more than 10, so you can take this option 10.5. Actually, let us take it as 10.39. Okay, clear? Is it clear to everyone? So you will be using the formula for unit power to compare the two turbines under same. You are comparing same turbine under different condition of head. Operating head is changed. The power you have to find if the head is changed to 60 meters. So you will be using this formula for unit power. Okay. The speed ratio in the petrol wheel, Pelton wheel operating under a head of 1600 meter is 0.48. What is the peripheral velocity of the turbine wheel? Speed ratio of the Pelton wheel turbine is given speed ratio is u, that is peripheral velocity, divided by under root 2 gh. This is given, this value is given as 0.48, and you have to find the value of peripheral velocity. Simple question. The operating head is 1600 meter, so u will be equal to 0.48 under root 2 gh. 2 into 9.81 into h is 1600. Solve it, tell me the answer. Yes, everyone, the values are quite close to each other. So if you solve it, you will get 85.045 meter per second. Use calculator to get the exact answer. Okay. In your RRB JE exam also you can use calculator, and for SSC JE also you can use calculator. So my advice will be to use calculator for solving these questions. Next question. A reservoir has a head of 50 meter and the flow rate for the turbine is 36 meter cube per second. If the runner speed is 180 rpm and the overall efficiency is 92%, then which type of turbine is this? I think this question I have taken, I think in the last month only, and there was a confusion for this question. The confusion was based on the operating head. If you say operating head is 50 meter, you can say that this turbine is Kaplan turbine, because the operating head is quite less. If the operating head is greater than 250 meter, this is Pelton turbine. If the operating head is less than 250 and greater than 60, in somewhere you will find 60 meter, then we say it is Francis. And if the operating head is less than 60 meter, it is, you can say, Kaplan. So based on the operating head you will say it is Kaplan. But अगर क्वेश्चन इतना इजी होता कि आप ऑपरेटिंग हेड देख के ही इसका आंसर बता देते, तो why they have given all these data of overall efficiency, speed and everything? What's the reason for giving all this data, right? So how to so you will say, sir, why you want to make the question complicated if it's easy? It's not like that. See, it is 60 meter, but it is close to 50. Okay, let's say if it is less than equal to, if I take this as 50 and less than equal to 60 meter, then this can be Francis also, right? It can be Francis also. I can take it as Francis also if for a small range. In somewhere you can also find it as Francis. Okay, so it depends. It depends. You cannot directly jump on to conclusion based on the head. Here you have to be, for assurance, you have to find the specific speed. The specific speed of turbine is n root p h power 5/4, right? Now, for a specific speed, you know the RPM. This is 180 RPM. You don't know the power. Head is known to you, which is 50 power 5/4. How you will get the power? Overall efficiency is equal to, it is equal to shaft power divided by rho g QH, and divide by 1000 it is, so this you can just remove it. This will be power, shaft power in kilowatt will be G is, you can take 9.81 into Q is 36 into H is 50. From here you will get the shaft power, okay, in kilowatt. Just get the shaft power in kilowatt, put it here, you will get the RPM. Come on, solve it, everyone. So you will get this value as 16245.36 kilowatt. Now just put the value of power here, you will get a specific speed. A specific speed you will get, if you put the value of power here, shaft power, you will get a specific speed as, yes, what specific speed you are getting? 172 something, right? or 177, 172 something, right? Now based on this specific speed, this comes as a Francis turbine, not Kaplan, because Kaplan turbine has a specific speed of more than, it's very, it has large specific speed. Around 600 RPM is a specific speed for Kaplan turbine. So this is a very, based on the specific speed, if you just see the head, then you can say Kaplan. But if you see the specific speed, this can never be Kaplan turbine, right? Kaplan turbine has no, itni kam specific speed nahi hoti hai, around 170 or 172 or 170 or less than 200, right? So that's why the answer will be Francis based on specific speed. Based on specific speed, the answer will be Francis turbine. Okay, you cannot say it is a Kaplan turbine. Clear? Next question. It is desired to increase the heat dissipation rate from the surface of an electronic device of a spherical shape of 5 mm radius exposed to convection. So we are having a electronic device जो कि spherical shape की बनी हुई है. It is made of spherical shape and this is having a radius of 5 mm. 5 mm radius, okay, and it is exposed to convection. Convection means it obviously outside this electronic device you are having some air or any fluid which is having heat transfer coefficient, because convection heat transfer takes place between a surface and a surrounding fluid. Surrounding fluid, let's say it is air, which is having heat transfer coefficient of 10 watt per meter square Kelvin. Encasing it in a spherical sheet. A spherical sheet means there is a covering around it. There is a covering around it. Sheet means a kind of a cover which is of a spherical shape like this, whose thermal conductivity is given. Thermal conductivity of this sheet is 0.04. For maximum heat flow, the critical diameter of the sheet will be, first of all, critical radius. Critical radius formula you must have studied in heat transfer subject. It is equal to 2 into K by H. This is the formula for spherical body. If the body is spherical body, you can use this formula. 2 into K. K is thermal conductivity, which is 0.04, and H is 10. From here you will get this value as 8 mm. In mm you will get this value as 8 mm. Now what, this is critical radius. Critical diameter will be equal to 2 times critical radius, which will be 16 mm. Okay. So this will be the maximum diameter, or this will be the diameter for which there will be maximum heat transfer from this spherical body. Okay. So आपने heat transfer में इस प्रकार का कर्व पढ़ा होगा, heat transfer and the radius like this. What is critical radius? Critical radius is that radius at which if you apply an insulation on a body, on a surface, then as the insulation will increase, the heat transfer rate will increase. At critical radius, the heat transfer rate becomes maximum. Okay. Next question. If one cylinder of a diesel engine receives more fuel than the other, then it is a serious condition for that cylinder and can be checked by. Let's say it is let's say there is a case of multi-cylinder diesel engine. Okay. Multi-cylinder diesel engine we are using in our, let's say we are having a car and we are having multiple cylinder in that. Okay. So you know about the firing order. It's not that at one time all the cylinder will be firing or they will be producing power. Okay, depending on the order of the cylinder, which cylinder will be firing, or depending on the firing order of the 4 cylinder. For example, this is a 4-cylinder engine, so we'll be using firing order 1, 2, 3, 4. So firing order will be 1, 3, 4, 2. So firstly the first cylinder will be firing or will produce the power, then third, then fourth, then second. Now let's say one cylinder receives more fuel. If one cylinder receives more fuel from the fuel injector, which is injecting the fuel, and it is receiving more fuel, then what will happen? More fuel means more combustion. More combustion means more temperature. See, more fuel, if the fuel will be more, then combustion will be more. Combustion will be more, then temperature will be high, and temperature will be high. Then is there any way to check the temperature? Temperature can be checked with the help of a device known as pyrometer. Pyrometer is basically a thermometer, okay, which will check very high temperature. Okay, so how you can check the temperature? By exhaust gases which will come out from the engine. You have to check the temperature of those exhaust gases, and from that you can identify that okay, for this particular cylinder, the gases which are coming from the exhaust valve are having the highest temperature. Okay, that means this is the faulty one. Okay, so judging the seizure of the piston, no. Checking the incomplete combustion cylinder, no. This is not correct. Only option will be option C, third only. Just by checking the value of the exhaust gas temperature coming from that particular cylinder. Okay, the cylinder which has received more fuel, that will have more combustion. That means the gases which will come out from the exhaust valve will be at very high temperature as compared to all the other cylinder. Okay, so just use a thermometer, check the exhaust temperature, and you will understand that this cylinder has received more fuel. Next question. An ideal refrigerator working on reverse Rankine cycle has a capacity of 3 ton. The COP of that unit is found to be 6. The capacity of the motor required to run the unit is. In this question, we are having an ideal refrigerator working on reverse Carnot cycle. Capacity, when we say capacity, that means we are talking about refrigeration capacity, that is 3 tons. And 1 ton is, here it is given as 210 kilojoule per minute. But since the answer is being asked in kilowatt, it will be better if we keep this in kilowatt, which is 3.5 kilowatt. So total capacity will be 3 into 3.5 kilowatt, which is, you can get from here, right? COP is given, you have to find the power input. So COP is equal to 6, which is equal to refrigeration capacity 3 into 3.5 by power input. So from here you will get the power input as 3 into 3.5 by 6. So you will get 1.75 as the answer. Okay, are you all getting this value? Next question. See, this is a match the following type question where some components of vapor absorption system are given, like generator, analyzer, rectifier and receiver, and their purpose is given, their function is given here. You have to match these components with their function. Okay, clear to everyone? You have to just match the function of these components. So in vapor absorption system, generator, analyzer, rectifier, receiver, these components are, you know what is the function of generator. Generator is basically used for generation of the vapor from strong aqua ammonia solution. So for A it will be 2. A it will be 2. Only one option has A as 2. That is option D. For analyzer and rectifier, analyzer is used for dehydration, and rectifier is used for removing the reducing dry ammonia. So this is 3. It will remove the water particles completely, rectifier. Okay, so B will be 1, C will be 3, and D will be 4. So the right answer is option D. Just by matching one option, you have got the right answer. Okay, and receiver stores the high pressure liquid ammonia. It is used to store the refrigerant. A cyclic heat engine operates on a Carnot cycle between the source and the sink temperature of 600 Kelvin and 300 Kelvin. If the heat engine receives 400 kilojoule of heat from the source, what will be the amount of heat rejected to the sink? Because this engine, the cyclic engine, is based on the Carnot cycle, for Carnot cycle, which is a reversible cycle, since Carnot cycle is a reversible cycle, and for reversible cycle, cyclic integral of Q by T will be equal to 0, or we can say the heat supplied by temperature at the heat supplied is equal to heat rejected by temperature at heat rejected. You have to remember this formula. You have to find the heat rejected. This will be simply heat supplied is 400 into 300 by 600. Okay. So you will get 200 kilojoule heat. Simple. Okay. Clear to everyone? Use this formula and you can directly get the value. Next question. In a modes test for a 2-cylinder 4-stroke compression ignition engine, the brake power was 12 kilowatt, whereas the brake power of individual cylinder being cut off. Injection cut off means it is a diesel engine. Obviously, it is diesel engine, so fuel injection is cut off. This is how you conduct the modes test. You firstly measure the brake power of all the cylinders working, and then you cut off each cylinder, okay, one by one, and then you measure the brake power. So the brake power of all cylinder working is equal to, it is equal to 12 kilowatt. Brake power when first cylinder cut off or one cylinder cut off means the fuel injection is cut off is 4.25 kilowatt. Brake power when second cylinder cut off is 4.75 kilowatt. So how to find the mechanical efficiency? Indicated power of first cylinder will be, it is brake power of all cylinder working minus brake power when first cylinder is cut off, that is 12 minus 4.25. You will get indicate power of the first cylinder. Indicate power of second cylinder will be brake power when all the cylinders working minus brake power when second cylinder cut off, that is 12 minus 4.75. Get the value. Find the total indicate power, which is indicate power 1 plus indicate power 2. Okay, you will get the value in kilowatt, and mechanical efficiency will be equal to total indicate power divided by, total brake power divided by total indicate power, which is 12 by indicate power total. Just find the value and tell me the answer. Yes, there are 5 options, don't worry about it. If you have solved the right, so this is 7.75 and this will be 12 minus 7.3. Okay, sorry, 7.25. Now you have to add it. Total indicate power will be 15. So this will be 12 by 15 into 100. Okay, simple. You will get 80%. Option D. Option E in this case. So like I was telling you, that doesn't matter if this question is having 5 options. You need to just get your right answer, okay, from all the 5 options. Next question. The enthalpy of the steam at the inlet and exit if the turbine are 3200 and 2700 kilojoule per kg respectively. If 50 kilojoule of heat is lost to the surrounding, not last. Find efficiency of the turbine. How are you going to find the efficiency of turbine? Tell me. Let's look at the tricky question. To solve this tricky question, you need to do one thing. First of all, you need to find the first you need to understand what is the efficiency of the turbine. This is equal to actual enthalpy drop to the isentropic enthalpy drop of the turbine. Okay. Now, actual enthalpy drop you cannot find like this. You have to find the isentropic. This will be simply 3200 minus 2700. But how you are going to find the actual enthalpy drop? Actual enthalpy drop you can get from this relation. H1 plus Q is equal to, or not based on the enthalpy drop. It would be better if you find this based on the actual work to the isentropic work. Okay. actual output from the turbine to the isentropic work output from the turbine. Isentropic work, actual work you can find from the relation that I am going to write, but isentropic work is nothing but enthalpy at the inlet of turbine minus exit. Okay, you can easily get the value of isentropic work based on difference of the enthalpies. This will be 3200 minus 2700, which is 500. But how to find the actual work? Actual work you can find from a steady flow energy equation, because heat is given. It will be H1 plus Q is equal to H2 plus actual work. So from here you will get the actual work. So 3200 minus 50, because this heat is getting lost, is equal to 2700 plus actual work. Okay. From here you will get the actual work. Actual work will be equal to 450. This is the actual work. 450, ideal will be, or isentropic will be 500. Simply you will get the answer as 90%. Okay, clear? Is it clear to everyone? Next question. I can see that most of the students have left the session. Don't know what's the reason for that. Don't worry, I will just take 5 to 6 more minutes and then I will leave the session. Okay, or stop the session. Practically, it is not feasible to design an engine which closely follows the Carnot cycle for the following reasons. Why it is not possible to make an engine which is based on Carnot cycle? The reasons are given. First reason, transfer of the heat energy at constant temperature is very difficult to achieve. Second reason, isentropic processes are very fast. Isentropic process means reversible adiabatic or adiabatic. Yeah, it's true. It's true that the reason why Carnot cycle is not practically possible, because if you see the process in the Carnot cycle and how these processes are basically arranged in a cycle, they are arranged like that firstly the process is a very slow process followed by a very fast process, then again a very slow process, then again a very fast process. So nature of these process, a very slow process of isothermal and very fast process of adiabatic, and again very slow process of isothermal, and then again very fast process of adiabatic. This makes this whole cycle impossible in practical sense. So these two are important reason for that. Next option, it makes use of small pressure ratio and thermal efficiency is not a function. These are not the reason for it. Okay, just given to confuse you. The main reason is the process in the cycle, which is constant temperature and reversible adiabatic or adiabatic. In their nature, they are very isothermal is a very slow process and adiabatic is a very fast process. And having these processes in a cycle one by one after other is not possible. इसी वजह से ये cycle possible नहीं है. Carnot cycle is not practically possible. A heat engine operating on Carnot cycle has an efficiency of 75%. If the lower temperature is 0 degrees Celsius, determine what could be the COP of the refrigerator working on the same cycle have. Simple question. The efficiency of the heat engine is 75%, 0.75, and COP of the heat pump is 1 by efficiency of the heat engine, which is 1 by 0.75. From here you will get the COP of the heat pump, but you have to find COP of refrigerator, which is COP of heat pump minus 1. Okay, so you will get 0.25. This will be 1.25, this is 0.25. But there is a question that has once appeared in SSC JE and once appeared in ISRO exam, that if they would have asked COP of reverse Carnot cycle, sorry, my mistake. That's how we should solve the question. If they would have asked COP of reverse Carnot cycle, then there would have been two options. It could have been COP of heat pump and it would have been COP of refrigerator. दोनों में से कोई भी हो सकता. Then आप किसको select करते हो? Which option would have you have selected? Now here they have given 0.33 only. What if they have also given 1.33 also? Then which option would you have selected? Tell me. 1.33 or 0.33? So always remember this fact that a Carnot cycle is a cycle which produces work output. A cycle which is based on reverse Carnot takes work input. If a cycle takes work input, its COP should always be greater than 1. So you cannot select COP of refrigerator. In that case, you have to select COP of heat pump. Okay, whenever you find this case, then always take COP of having more than 1. So this you would have selected in this case. Okay, COP of heat pump. Next question. A gas turbine plant operating on ideal Brayton cycle is designed to get maximum possible work output. If the power plant works between temperature limits of 400 and 900, find the efficiency of the power plant. Because the power plant is based on maximum work output and that is on Brayton cycle, for maximum work output the efficiency is equal to 1 minus square root of minimum temperature by maximum temperature. Simple. Just apply this and you will get the answer. Okay. So that is 1 minus 2 by 3, that is 33.33. But for same Brayton cycle, there is a condition for maximum efficiency. The maximum efficiency will be 1 minus minimum temperature by maximum temperature. Okay, but in this condition the net work becomes 0. For maximum work output, the work output is maximum, then efficiency will be this. Okay. While subjecting the water to heating techniques, identify the sequence in which the various phases of the steam are formed upon continuous heating of the sample. So suppose you are heating the water. Okay, you are heating the water and that water is obviously less than saturation temperature, so it will go through many phases. Okay, at constant temperature of, let's say, 1 atmospheric pressure, you are heating the water. So firstly that water will be in the subcooled liquid region. It will be subcooled liquid. Then that will become saturated liquid. At this point it will become saturated liquid. Then it will become wet steam. Then it will become dry saturated vapor or steam, and then this will become superheated steam. Okay, now based on this option you have to answer the question. Based on the option, the answer will be only option A. Firstly it will be wet, then dry, then superheated. But if they start from subcooled liquid, then firstly it will be subcooled liquid, then saturated liquid, then wet steam, then dry saturated steam, then superheated steam. This will be the order. Okay. An ideal Otto cycle works between minimum and maximum temperature of 300 and 1800. What is the compression ratio of the cycle for maximum work output? If gamma is 1.5. In Otto cycle, for maximum work output condition, the temperature at the after compression and after expansion becomes geometric mean of minimum temperature and maximum temperature of the cycle. Okay, this is the formula. And what is compression ratio? Compression ratio is T2 by T1 is equal to V1 by V2 gamma minus 1. This is compression ratio, V1 by V2. So compression ratio will be T2 by T1, 1 by gamma minus 1. Because for maximum condition, for maximum work output condition, T2 becomes a square root of minimum and maximum temperatures. Minimum temperature is nothing but T1 and maximum temperature is T3. So you can say this is equal to square root of T1 T3 by T1 power 1 by gamma. Or you can also say that if you multiply by a square root of T1 in the numerator and denominator, so what will you will get? Tell me. You will get compression ratio is equal to T3 by T1 1 by 2 gamma minus 1. Okay. T3 is the maximum temperature, which is 1800. T1 is the minimum, that is 300. 1 by 2 gamma, that is 1.5 minus 1. 1.52 into, तो ये 1 हो जाएगा, तो ये 6 आ जाएगा आपका डायरेक्टली. Okay, clear? Is it clear to everyone? Next question. So here they have written about some cycles. In the list 1, there some cycles are written, and the list 2, all these cycles, auto, diesel, Carnot, Brayton, they depends on some parameters, like some depends on the compression ratio, some depends on temperature limits or temperature ratios, some depends on volume compression ratio. Okay, so all these auto, diesel, Carnot depends on some parameters. Okay, you have to just match the parameters on which the efficiency of this cycle depends on. Okay, for example, efficiency of the Otto cycle depends on compression ratio. The compression ratio क्या होता है? It is ratio of the volume V1 V2. It is also called volume compression ratio. So for A, you can simply say it is equal to A. For A, it will be 3. For A, it will be 3. So this is the match the following. This is A, B, C, D. A will be 3. Only 2 options. Option B and option D cannot be the answer. Diesel cycle. Diesel cycle efficiency depends on compression ratio and cutoff ratio. Cutoff ratio and compression ratio. For B, it will be 4. So B will be 4. So option A will be the answer. Okay. Next question. Consider the following statement about two-stage reciprocating compression. For same pressure ratio, the volumetric efficiency of a two-stage compression is more than that of a single-stage compression. Obviously, two-stage means multi-stage compression. Multi-stage compression has more efficiency than single-stage. That is correct, right? That's the reason why we do multi-staging. So this is obviously correct. A two-stage compression requires minimum work when intercooling is perfect. That is also correct. Intercooler pressure is the average of the inlet. This is wrong. Intercooler pressure in a two-stage compression is not the average. It is the geometric mean, not the average, but the intercooler pressure is, this is inlet pressure, this is delivery pressure. If it is a two-stage compressor, then intercooler pressure is geometric mean of the inlet and delivery pressure. Okay, clear? So this option is not correct. The right answer is option B, 1 and 2. Next question, also the last question of today's session. Consider the following statement. Stalling is the separation of the flow from blade surface. What is stalling? Suppose there is a compressor, and on compressor has this kind of curved blades, aerofoil blades. When the flow will be attached to the surface like this, the air particles will flow on this blade like this. This is a blade curvature. On this, the air particles will flow like this. This is the attached flow. Okay, this is called attached flow. What is the meaning of stalling? Stalling is the start of separation of the flow from the blade surface. So there will come a point when the pressure in the flow direction will start to increase, and then start of the separation will start to take place. The flow will start to separate. This is correct. Surging leads to physical damage. That is also correct. Mass flow rate is minimum. No, this is wrong. Choking, when choking take place, mass flow rate is maximum. So option third is not correct. Which of the following is correct? Option 1 and 2. Clear? That's all for today. Rest of the questions will take in the next session tomorrow. I think tomorrow the session, if the session will be there tomorrow, if it will be there, I have to check with my team first. I think I have arranged a session for tomorrow. If the session will be tomorrow, then it will be on 50 best question on fluid mechanics. So this session will be tomorrow. If it will be tomorrow, I will tell you that. I will inform you. But if not tomorrow, then it will be on Monday. Okay. 90% it will be tomorrow at 8 p.m. But if not, it will Monday. One thing I want to also tell you everyone and ask you everyone that from Monday onwards, I'm going to be involved in. I will be busy from 6:30 p.m. to